Today we're going to finish Unit 1, Acquisition 2. The topic for today is ions. So first we'll start, what is an ion? An ion is an atom that has gained or lost electrons and has either a positive or negative net charge. Important to note that the only way we can form an ion is by gaining or losing electrons. Remember, we said the number of protons never change. So how do we get a positive ion if we're not adding more protons, if we're not adding more positive charges? So if we had a positive ion, it's positive because it lost electrons. Positive ions lose electrons. It's like subtracting a negative. When you subtract a negative, your answer is positive. When you lose electrons and electrons are negative, your charge is positive. We call positive ions cations. We can also have negative ions. Negative ions gain electrons. We call negative ions anions. An easy way for you to remember which one is which: cations are positive because cats have paws. So those cations are positive. When we are looking at charge, we are going to look at the two subatomic particles that are charged, which are the protons and electrons. Remember, neutrons are neutral. So charge depends on the difference in protons and electrons. If you have more protons, then your ion is positive, since protons are positive. If you have more electrons than protons, your ion would be negative. First example. An ion has 17 protons and 18 electrons. Determine the charge. So charge depends on the difference between our protons and electrons. My difference is going to be 1. The charge must always have a number, but it also needs a sign. Is it going to be positive or negative? Well, I have more electrons than protons, so the charge would be negative. Typically when we do charge, we put the number first and the sign after. So this would be a 1 minus charge. Let's look at another example, example 2. An ion has 12 protons and 10 electrons. Determine the charge. So again, we want to look at the difference between our protons and electrons. My difference would be 2. I have 2 more positive charges than negative charge, so my charge would be 2 plus. Well, how does charge fit into notation? So remember from last lecture, we had our A to Z notation, where A represents the mass number, Z represents the atomic number, and X is the element symbol. If your notation looks like this, it's going to be an atom. If it's an ion, we are going to add a charge on the upper right. So B represents the charge. Let's look at two examples using this notation system. So let's say I had potassium. Z, the bottom number, is the atomic number. Potassium has atomic number of 19. Atomic number is equal to the number of protons. Potassium has 19 protons. Mass number is equal to the protons plus the neutrons. My mass is 39. If I subtract out my 19 protons, that leaves me with 20 neutrons. If you ever see a charge without a number, it just means that it's 1. So potassium has a charge of +1. So if I have 19 protons and protons are positive, and my charge has to equal +1, how many electrons would we have? 18. Remember 18, we got 18 because electrons are negative. So if I have 19 positives and only 18 negatives, my charge is going to be +1. Let's try one more using this notation system. Let's say we had this nitrogen anion. And again, we want to determine the number of protons, the number of neutrons, and the number of electrons. Again, the number of protons is equal to the atomic number. The atomic number is the number in the lower left, so I would have 7 protons. If I take my mass number of 14, subtract out my 7 protons, that gives me 7 neutrons. Protons plus electrons will get me to my charge. So I have 7 positives, but my charge is -3. I have 3 more electrons than protons. That means I must have 10 electrons. If I have 7 positives and 10 negatives, that gets me to my net charge of -3. Last thing really quick, last lesson we talked about the other notation system where we have element, mass number. If we're using this notation system, assume that it is always an atom. It is always going to be neutral. Typically, if you're going to have an ion, you're going to see the A to Z notation instead of our isotopic notation system.